Hello, today I want to share with you what I've been working on for the past month, going from OpenRocket to making 3D models and most importantly making an air brake system. But first, I want to thank the faculty, my professor Bruno Guerreiro for his help along this project, and my colleagues João, Marcos and Tiago, since they were part of the team. The first thing I did was look at the last year's design. Their objective was to make a rocket that could reach the height of 3000 meters. We made some changes to their model, like moving the tube coupler as well as making it 15 centimeters or 1 rocket diameter in size, as well as adding the shock cord necessary for the rocket's parachutes. When testing this rocket model, we could see that the rocket reached a height of 3000 meters. That's good, right? Well, no, because it reached a height of 3009 meters, just above the desired height, so we needed to add air brakes to the rocket. I went immediately to CAD and designed a better model than just an approximation made in OpenRocket. Some additions were made in the CAD model, including the rocket separation method and the deployment of the parachutes. The separation utilizes a pneumatic piston to push the tube coupler that breaks shear brake screws and ultimately splits the rocket in half. We decided that the use of an airsoft canister is the best method for these purposes, since we can adjust the pressure and use it multiple times. The drogue should deploys immediately after separation, and the main parachute only opens at 250 meters off the ground using a standard sender. Now what really matters is the air brake system, since it was the main focus of these projects. I did the first design of opening 4 different drag surfaces by rotating a servo, but I had no idea what I was doing, so I left it for Marcos, the student of mechanical engineering, to take care of it. While he worked on that, me and João started working the plugin for the OpenRocket. What really helped was the work already done by the High Powered Rocketry Club organization at WPY. Their work was very close to what we desired, so by making a few changes, we were able to generalize the plugin so that it worked with any air brake system. We kept the use of the PID system to control the opening and closing of the air brakes and added a wind-up to it. Now, depending on the desired height and with a predicted altitude based on calculations, we can get a really good result in the OpenRocket. With this system, for the desired altitude of 3000 meters, we were able to get within a margin of a meter, and if we were to optimize the PID system, we could get even better results. Now, having the virtual version done, we can implement the software for a real use. By giving the simulation with air brakes as a lookup table to the Arduino and performing the exact same calculations made in the plugin, we can open the servo the correct amount to reach 3000 meters. The system worked by passing the information from the computer to the Arduino, one step at a time, since the Arduino memory is too small for all the data. The only problem is that 200-second rocket simulation took about 10 minutes to run on the Arduino, and we did not want to wait that long per test, so a version of the code was made in C to run on the computer. Now we could test any simulation in less than a second and only pass the Arduino the final one.